The second theorem is the angle at the center theorem, which states that the angle subtended by a chord at the center of a circle equals twice the angle the same chord subtends at the circumference of the circle. Let's look at that a little closer. The angle subtended by a chord at the center of the circle equals twice the angle that same chord subtends at the circumference of the circle. When we subtend a chord at the center of a circle, we take the two end points of the chord and connect them both to the center of the circle, forming an angle at the center of the circle. When we subtend the same chord at the circumference of the circle, we take the two end points of the chord and connect them both to any point that lies on the circumference of the circle, forming an angle at the circumference of the circle. This theorem states that the angle formed at the center of the circle equals twice the angle formed at the circumference of the circle. In other words, angle AOB equals twice angle ACB. Once we have subtended the chord at the center of the circle, we can subtend the same chord at any point on the circumference of the circle. All angles subtended by that chord at the circumference of the circle are in fact equal, but we will look at that a little later. We will first prove this theorem. Given circle center O, with chord AB, and any point, C, on the circumference of the circle, we are required to prove that angle AOB equals twice angle ACB. To start this proof, we join points O and C, and extend the line. In triangle AOC, angle O1 equals angle A plus angle C1, the reason being that the exterior angle of a triangle equals the sum of the two opposite interior angles. OC and OA are radii of the circle, thus they are equal, so we can mark this information on the diagram. Since OC and OA are equal, this makes triangle OAC an isosceles triangle. Therefore, angle A equals angle C1. That means that angle O1 equals twice angle C1. Similarly, angle O2 equals twice angle C2. Therefore, angle O1 plus angle O2 equals twice angle C1 plus twice angle C2. Taking out a common factor of 2, we get angle O1 plus angle O2 equals twice angle C1 plus angle C2. Angle O1, together with angle O2, form angle AOB. Likewise, collectively, angle C1 and angle C2 form angle ACB. Therefore, angle AOB equals twice angle ACB. There are three basic corollaries to this theorem that we will cover. A corollary is a derivation of a theorem. You are not required to prove these corollaries, but you are expected to know the theory behind them. The first corollary is, the angles subtended by the same chord, in the same segment of a circle, are equal. Consider the diagram we touched on earlier. Chord AB subtends angles, ADB, ACB, and AEB, at the circumference of the circle. Since angle AOB equals twice angle ADB, and twice angle ACB, it follows that angle ADB equals angle ACB. Similarly, since angle AOB equals twice angle ACB, and twice angle AEB, it follows that angle ACB equals angle AEB. Therefore, angle ADB equals angle ACB equals angle AEB. The second corollary states that equal chords subtend equal angles at the circumference and center of a circle. We have just seen that any one chord subtends equal angles at the circumference of a circle. If a circle contains more than one chord, and those chords are equal in length, then the angles subtended by those chords are also equal. In other words, given two equal chords, PQ and AB, the angle that those chords subtend at the circumference of the circle, namely, angle PRQ and angle ACB, respectively, are equal. Similarly, two equal chords subtend equal angles at the center of the circle. In other words, if PQ equals AB, then angle POQ equals angle AOB. The third corollary we will cover is directly based on the angle at the center theorem. This corollary states that the angle a diameter subtends at the circumference of a circle is a right angle. Since a diameter is a chord that passes through the center of a circle, the angle at the center of a diameter is 180 degrees. And because the angle at the center of a circle equals twice the angle at the circumference of the circle, it follows that the angle subtended by a diameter at the circumference of a circle is half 180 degrees, which is 90 degrees.